So the objective of this video is going to be to determine the most basic nitrogen within a compound or between compounds. And so we're going to go through a series of steps, and although some of these steps might be quite obvious, with repetition it should become very familiar, and it should be very easy to figure out which nitrogen is the most basic using the rules provided. And so the first rule is to find a nitrogen with a lone pair. This one might be a little obvious, but some students sometimes forget that the NH3+ doesn't have a lone pair on it. And if it doesn't have a lone pair on it, then it's not going to be able to act as a base and pick up a proton relative to the nitrogen that's only connected to three other atoms and has a lone pair, which might be able to. And so after you find out the nitrogens that have a lone pair, the next step is to decide whether the lone pairs is being used for stabilization. And so there's two main ways that we can use the stabilization can be provided. The first one is going to be resonance. And so if we look at an amide, which is adjacent to carbonyl, the lone pair on this nitrogen can resonate with the carbonyl compound, which results in this structure. The second way we can find stability is going to be through aromatic compounds, or aromaticity. And so sometimes a lone pair might be part of a pi system, such as the case here. The lone pair is being counted for the 4n plus 2e electrons. And so once we find out if there's a nitrogen present with a lone pair, we decide whether the lone pair is being used for stabilization. The two main ways stabilization is provided is through resonance or aromaticity. And so if the lone pair is being used for stabilization, it won't be able to act as a good base because that lone pair isn't available to pick up a proton or act as a base. And so then, in determining, it would be the lone pair that isn't being used for stabilization that would provide or be the most basic within the compound. There might be a situation in which the lone pair isn't being used for stabilization, and so there might be two nitrogen compounds that you're deciding from. That may be led to situation number 3, where you have a lone pair and it's not being used for stabilization, but there's two hybridizations between the two nitrogens. And so what you want to do is check for the hybridization of the nitrogen atom. So the two situations you could have is a nitrogen having an sp2 hybridization, or it could be a situation where it has an sp3. And so when looking at the relative hybridizations, the sp2 has more s character in terms of the orbital, and it puts the lone pair closer to the nucleus. So if it's closer to the nucleus, then it's harder for that lone pair to go out and pick up a proton. And so between sp2 and sp3, sp3 would be the better base. And then ultimately, if the hybridizations are the same, then you're going to be at situation number 4. And when you get to situation number 4, you're going to check and compare the pKa's. And so you would need some literature, either your textbook or another resource, that would give you pKa's of those nitrogen atoms. And then you would be able to compare between the two. If the pKa is lower, then if one pKa is lower than the other, then it's going to be more acidic. If the other one's higher, then that one's going to be more basic. And so you would have to look at the pKa values to determine which one's more basic.